Great to see everybody. My name is François Baldassari. I'll introduce myself in the next slides, but I'm the founder and CEO here at Memfault. And today I'm going to talk about launching an IoT device, which admittedly sounds like a really broad topic. And so, of course, we'll talk about some aspects of the endeavor. And as an embedded software engineer, I, of course, have a specific point of view and will likely talk a little bit more about embedded software than the rest of the process. A note about me. So as I mentioned, I'm the founder and CEO here at Memfault. But I think more importantly, I'm a firmware engineer. I've been building connected devices at Oculus, the virtual reality company, at Pebble, which was a wearable electronics company that made the first smartwatch. And I started my career at Sun Microsystems. I've always been really into tools. I was the engineer who was spending his evenings building better scripts and tools and automation. And this kind of hobby turned into a job when I ended up building tools and scripts and infrastructure for other companies by starting Memfault. The last thing that you may be interested to know is I write a good bit about embedded software, first and foremost, on the Interrupt blog, which you can read at interrupt.memfault.com. So what are we going to talk about today? You know, the structure of this talk is very simple. I want to cover two main things. The first one is shipping on time. Of course, there is no silver bullet, so I'm not going to give you this one weird trick to ship on time. But I think there are many things that we can do to de-risk our timelines and make sure that we don't have dependencies where we don't need to have dependencies. And I think even being aware of the timeline and the constraints helps us make good decisions that let us ship on time. And the second thing that I'll talk about is how do we de-risk the launch of the products? Because once we've gotten all the way to ship, the products is on shelves or in your first customer's hands, the work isn't done, right? Making sure that the product is successful is an art in itself, and there are techniques and tools that we should use to do that. At the end, we'll have a Q&A, so don't hesitate to ask questions using the Q&A button in Zoom. Okay, so shipping on time, that's perhaps the thing that as product managers and program managers, or the product managers and program managers that we work with care about the most. And it's, you know, it is truly a job because building a hardware product, as I'm going to show, is an extremely complex endeavor where you know, you need to orchestrate mechanical engineering, electrical engineering, manufacturing, test automation, marketing, many other things that you know, don't necessarily work on the same timelines. And typically, one of the tools that we use to at least align on you know, the timeline and the milestones that we're going to go through from start to launch looks something like this. I think those of you who have worked, especially on a consumer product, have likely seen this type of timeline many times. And it's made up of a number of, I think, pretty standard milestones that I'm going to go over. It's originally inspired by the folks at Apple who use a very kind of strict process for new product introduction, which is what NPI stands for. So first, let's talk about the beginning of our program, the proto phase. So, you know, and here the timelines that I'm going to share are, I would say, the fastest you might be able to go through this. So I'm working under the assumption that we're trying to go from start to finish kind of as fast as we can for a product that's pretty well understood, where there's not a lot of research up front. We don't have to invent new things. We don't have to solve unsolved problems. We have a pretty good product brief, and we're going to try to launch it as fast as we can. So first is the proto phase. What's the proto phase? The proto phase is figuring out what we want to build. And so it's the time where you're going to be iterating quickly on prototypes that you're 3D printing. Perhaps you have even different types of prototypes. There's oftentimes a looks-like prototype that your mechanical engineering team, your design team might be working with. And then you have a works-like prototype, which might just be a dev board that your electrical engineers and your firmware engineers are working on. The proto phase is the longest, but note that 12 weeks is not a lot of time, right? To do things like figure out which sensors you need, figure out how everything's going to integrate together, and come up with a product architecture that's going to work. By the end of the proto phase, you likely have a works like and a looks like prototype that's by no means final, but that can be shown to your executive team, that can be shown to some customers, and that will roughly represent what the product will do and look like. After that, we'll go into a couple of phases that are kind of engineering milestones, and it's EVT, DVT, PVT. Each of those gets progressively closer to a final product. And so you might start, you'll start with EVT, which is your engineering validation tests. At that point, you probably have a handful of configurations, your engineering designs, but your engineering designs are finalized. You're not going to make drastic change to the product at this point. But for example, let's say you have an accelerometer in your product, and you're not quite sure that one or another is going to meet your spec. So you might build 3 different configurations with 3 different accelerometers. EVT is getting EVT right is a crucial phase to shipping on time. And in fact, all the programs that I've worked on have succeeded or failed at the EVT moment. A successful exit to EVT typically meant a launch on time. And unfortunately, I've also been on programs that have seen EVT1, EVT2, EVT3, EVT4, even EVT5. And of course, each time, you've got to do a whole spin, which means at minimum, you're spending 4 weeks kind of iterating on your EVT design. And so, of course, if you get to EVT5, that's 4 times 5, that's a 20-week delay, right? And so, the success criteria, of course, here is that one of your configuration works just like you wanted it to. And we'll talk about the software side because in order to make that determination, you'll need software to be in a specific state. But by the end, it's not cosmetically perfect. It's probably being manufactured using still some soft tools and some test stations that are not final. The yield is probably terrible, but your EVT device should look and feel roughly like it will in the end. And you should have a couple configurations that de-risk the major subsystems of your program. Once you've exited EVT, you enter DVT, where the point of DVT is to get to one final configuration, sort out the cosmetic problems. So you probably have a station that scratches your devices sometimes, or things like that you have to hammer out during DVT. And by the end of DVT, you're not at production yield. You're not manufacturing as fast as you'd want to, but you have one final configuration and it's making it through all the manufacturing stations and everything passes. At the end of DVT, you have a unit that's almost sellable. It probably has a couple issues because nothing's perfect. There's oftentimes one major problem in our programs that we carry through DVT and PVT even, but it's close. And once we exit DVT, we enter PVT, which is at that point, we're not optimizing the device at all. The device should be final. We're just optimizing manufacturing because we want, by the end of PVT, we should be able to get the yield and the speed that we expect to hit our ramp targets. Each of those phases, how long does it have to be? Well, oftentimes you're manufacturing in China and going through an actual build will be at least 1 to 2 weeks that your team is going to spend in China. So already there's 2 weeks of time that are consumed here. And then of course between the phases you need enough time for your engineers to take in the data from the builds, make the changes that they need to make, iterate on the design if needed, troubleshoot what needs to be solved, and then submit another design for the next build. So realistically, you're looking at probably 8 weeks between each of these milestones on a very, very aggressive timeline. You might be able to squeeze it down to 6 weeks, and I've done it on some program, though your engineers will not be happy with you. And last but not least, as we exit the EVT, DVT, PVT stage, we're manufacturing at the speed and yield that we want. It's never quite that easy, but theoretically we are, right? There's oftentimes a couple issues. We start going into ramp. There's usually a short pause while we tweak a couple of things. We make sure all the right kind of parts are in the factory, and we kind of prep for ramp. But then we start ramp. And ramp, I think for people who haven't worked in the industry, which I think all of you have, ramp is something that I often have to explain. Why do they start making iPhones so much earlier than the launch dates? And it's because making enough for the launch takes a long time. If you're making 50,000 devices per day, which is a pretty serious throughput, and you need 500,000 for launch, that's 10 days of full-on manufacturing in order to get to launch. Oftentimes those numbers those timelines are much longer. So you start doing full-scale manufacturing. At that point, your line might be running 24/7 and just producing devices on 3 shifts until you have enough inventory. You've shipped it into Best Buy and Amazon and all these people, if you're in a consumer device or whatever your integrators and resellers are, and you're ready for launch. So between ramp and launch, I put in 4 weeks. It really depends on how fast your line can run and how much inventory you need for a successful launch. But launch is the exciting part. We've got a device, it's on the shelves, people get to use it. And oftentimes when we think about the NPI program, this is where it ends. And we're going to talk about what happens next in a second. But first, I want to talk about I'm going to talk about how do we optimize this process. And as I said here, very important is this very, very aggressive program is 1 year long. I'll be curious. I think I have a poll coming up, which is asking you, how quickly you've gone through NPI. 1 year is I think as good as it gets, although I'm sure some folks have managed to do it in 9 months or less on some very specific programs. But I think teams that can execute a full NPI launch in 1 year are operating at a really, really high level. And typically that means you didn't run into any major showstoppers and you were very disciplined about hitting each of your milestones on time. So before we go forward, I'd love to hear from you. First of all, does this timeline align with what you've seen, right? It's like, how long did your last NPI program take? I'm about to launch the poll, so you should be able to answer it now. And I'll be curious to see how many people say less or equal to 12 months, because that's kind of the most aggressive. And as I'm seeing, we're seeing actually a pretty good distribution. I'm gonna give you a few more, 30 more seconds to vote. But at this point, 18 months seems to be the winner. 12 to 18 months seems to be the winner. I'm going to share the results. So it looks like we've got a pretty kind of good distribution, with 18 months being the most popular answer, and we see about half of the answers that are higher than 18 months. I think this is pretty typical. I've worked on many programs that are actually 2 years long. That's a good timeline when you're working on a complex product, especially one that's not just an iteration over what you've built before. And of course, to the 6 people who've been on programs that have taken 12 or less months, congratulations, that's very fast. And I'll be curious to see in the comments, how you've accomplished that, what the learnings were. Okay, so back to this. A couple of things that we have to look at beyond just this NPI program. I think there's some activities that happen on a different schedule. And so the first one I look at, and the one we're going to talk about most here is firmware, which is what I know about the most. So what about firmware? Well, the milestones for firmware have to support your overall hardware roadmap, but they're a little bit different. First, much before your proto build is ready, your firmware team needs to have bring up complete. What does that mean? That means that they have to be able to exercise they have to have written the minimal driver code for every major subsystem so that you can verify, at a command line level that they're working, and that you're able to actually talk to them with your software. Once proto is done, at some point before EVT, you need to get to the point where what I call hardware test is complete. That means that you have a minimal firmware that can let a user try every major piece of functionality of the device. It's probably not going to work very well. It definitely doesn't have all the bells and whistles, but at the very least, you can, if the device has a display, you can look at the display and see a simple UI. If the device has audio, you can play an audio file, and so on and so forth. After EVT, between EVT and DVT, you need to get to the point where your manufacturing software is locked. Because remember, DVT is the moment in your program where you're operating more or less a production line as it will be during ramp. And so your manufacturing firmware is part of that. Whatever software is running on the device as they go through the manufacturing line has to be complete by DVT. And then, of course, by PVT, we're doing the pre-run for ramp. And so at that point, your launch firmware needs to be complete. Whatever firmware will be on the device at the time they get on the boats and ship back to your logistics centers has to be ready by PVT. Why? Because PVT units are what's called revenuable. Oftentimes, you will actually sell your PVT units, provided there's no major issues with them. And so they, of course, need to have the firmware that will go in on the device that gets sold. Last but not least, you'll see my last milestone, which is the day zero firmware. This is not something every company does, and I'm going to talk about it. I have 2 slides on it specifically. But the day zero firmware is a release that we do once the devices have left the factory, but before they're unboxed by the customer, that actually implements the last bits of functionality that we didn't have time to do before. And so, these milestones are pretty inflexible. And as you consider not just your hardware schedule, but your software schedule, it's good to have them in mind. But of course, firmware is not all. We have to also look at, what about marketing? They'll have some dates. And what about factory automation? They'll have some dates. The software that runs on your actual test stations, it actually can be quite complex, especially if you have calibrations and some proprietary manufacturing techniques. And what about cloud software that has to be built ahead of time? You start accumulating more and more of these dependencies. And I think what oftentimes make these programs really difficult is this mess of entangled dependencies that sometimes we can't work our way out of. And I've even seen sometimes circular dependency where 2 teams are waiting for each other to do something and no progress gets done. So because I'm a firmware guy and I mostly think about the interaction between software and hardware, I'm going to share 4 things that I've done in the past to disentangle and decouple dependencies between your software and your hardware. And those 4 things are test-driven developments, doing those day zero updates that I already talked about briefly. I think some sort of a typo, a strong HAL. We'll fix that before we share the slides. And then, of course, splitting the manufacturing and the app firmware. And so I'll tell you how each of those things can save us time and make the program less likely to slip. So first, let's talk about test-driven development. And I'm going to cover these briefly, but of course, we could do a whole talk about some of them. And in fact, we've written full posts on Interrupt about some of these techniques. So I refer to them when they exist. Test-driven development is building software and firmware against a software test harness rather than real hardware. So for example, you might use simulation, right? You might use something like Renode to simulate your hardware and do all of your software development against that. or you might build, use a unit testing framework like CPPU test to run some submodules of your code on your laptops rather than on your devices and exercise them that way. And test-driven development, oftentimes people think of it as a way to make sure the quality of your code is of a certain level, but it's also a really great way to decouple hardware and software development, because you can start your test-driven development, you can start building your firmware before you even have a dev board. So this allows for development to proceed before the hardware is ready. It gives you faster iteration speed because, believe it or not, recompiling, rerunning, and testing things in a TDD framework takes seconds rather than minutes on a real development board, which adds up throughout the program. And it also has the other benefit that it gives you a robust set of tests that you can also be reused to support development and make sure the quality of your product is up there. So first technique is test-driven development, which lets you start software development even when your hardware isn't ready. The second technique is day zero updates. So what's a day zero update? I talked about it a little bit. It's an update. It's basically having your final software, the one that you expect your customers to use, not be the one that's loaded in factory, but actually be an OTA, an over-the-air update that you do like a couple days before the devices are unboxed. Basically, when the customer opens the box, the first thing that happens is they update the device and they get the real last software. What does that give you? I think, of course, this has downsides. You may not want your customers to have a software update be their first experience. Although realistically, 6 months from now, when you have a new software update, this will be the experience of your customers because you're not going to keep updating the software in factory. So in fact, it's likely that this is just going to be a pretty common experience for your customers. But it also lets you decouple your software golden master, your kind of very last software version, from your ramp timeline, which can sometimes take a long time. And so you can extend your software development schedule by 4 weeks or more. And just to illustrate that, you see around the PVT timeframe, we have our launch firmware, which is the firmware we're putting in the box before it goes out to the customers. And then before launch, we have our day zero firmware. And basically these two, the time between these two milestones, which if you remember our kind of timeline earlier, is basically between 6 and 8 weeks, is additional development time that you can use to make sure your firmware is as good as possible. So I'm a big proponent of day zero updates and use them on most of my programs. Using a strong hardware abstraction layer, that's what HAL stands for. This is a little bit more work up front. And so I think not every program will decide to make that decision, will decide to make that move, but using a cross-platform operating system that's not chip dependent and that isn't necessarily provided by one of your hardware vendors, and that can easily be ported to new hardware, makes it more likely that if you have to make a change at the last minute in your program, you don't also have to redo a lot of your software. I'm a big fan of the Zephyr project, which is an open source real-time operating system, which now has buy-in from some really some leaders in the semiconductor and device manufacturing businesses. And a couple of reasons to do it. One is, of course, you decouple your firmware from the underlying hardware further. So it becomes easier to do test-driven development and becomes easier to kind of build it in isolation. Number two is, and this is very topical, in the event of supply chain constraints, you now have optionality, right? Because the changing microcontroller, changing a chip becomes much less painful. And so if you actually realize that your forecast is going up, you need more chips, but your current vendor won't sell them to you and you have to change vendors. This is a tough decision, but having used the hardware abstraction layer will let you actually make it with a little bit less pain. And last but not least, it lays the ground for code reuse on future programs. I think that I've worked at companies where every time we started a program, we would create an empty repository and start writing software from scratch. I think those days are gone. Increasingly, the software that we build has a lot of value, and being able to carry it from program to program without just copy pasting things around becomes really important and really strategic. And so by using a strong hardware abstraction layer, you can build multiple programs out of the same code base. And so this is something that will yield dividend program after program. Last but not least, we want to split manufacturing and app firmware. This is very tactical, but I've seen it have such a huge impact on some of the programs I've worked on that I'm continuously reminding people to do this. So what's our manufacturing firmware? The manufacturing firmware is the firmware that runs on the assembly line. So when we do our calibration test and all of our tests on the assembly line, we have, of course, some code that's running on the device itself. And so what I'm recommending is that we have a purpose-built firmware on the manufacturing line, which changes very rarely and is completely separate from the application firmware. So you don't basically load your application firmware until the very last test station on the line. This lets you iterate on the application firmware without impacting the manufacturing firmware, which is really important, right? If you're making a change to the way that your UI looks in your application firmware, you don't want to risk introducing a regression on your manufacturing firmware. It also lets you continue working on that firmware after DVT, because you remember we lock the manufacturing firmware at DVT. If your manufacturing firmware is the same as your application firmware, now you have a problem because you've locked it. And it also saves some code space because you don't carry your manufacturing code inside of your main application. So you can basically, they don't coexist, so you can reuse code space for both. I've gone back and forth on this recommendation early in my career because there is one major downside to splitting the manufacturing and the application firmware, which is that you might have dependencies between them. I think something that happened to me in the past is, we had an accelerometer in a device that I worked on, and that accelerometer had different configurations, including basically its range. Does it measure, 4 Gs or 8 Gs? And we changed the range mid-program, and we had 2 different firmwares, and we changed it in the app firmware, but not in the manufacturing firmware. And now the calibration was all out of whack. So if you do split those two, which has tremendous benefits, make sure that you have a way to manage the dependencies between them, like the sensor configuration. Okay, so that was kind of some techniques to get to a successful launch. And I noticed that some folks asked about DVT and PVT. Colleen answered, but I'll also say it for the group. DVT is design validation test, and PVT is production validation test. Sorry I didn't mention them earlier. You can, by the way, find those everywhere online. In fact, Anna at Instrumental, which is a company that we like a lot here at Pebble, wrote a post about it that's really good. So if you go check out the Instrumental blog, they write at length about EVT, DVT, PVT. So let's talk about de-risking launch. So congratulations, you've launched. It's happening. Yeah. It's certainly a great feeling. There are plenty of reasons to celebrate, and there's basically a 48-hour period where everything feels amazing, and then of course the hard work of having a product in the field starts. So what happens after those I would say the high of the launch is you start facing bugs and RMAs and security issues, and then you realize that there's a couple of features that you really wish you could have squeezed in, and what if we could squeeze them in post-launch? You start getting customer support requests and complaints. You start getting reviews on Amazon if that's where your product is sold. And so we got to get back to work. So what do we do about that? And before I go into techniques we can use to make the post-launch, as easy or as the least painful we can be. I just want to convince you that no matter how good you are, this will happen to you. I have never seen a launch where there weren't some issues post-launch, some debugging required in the field, some customer support kind of issue that overwhelmed our teams for a bit. And so here's a couple data points you can use to convince yourself of this. You know, Jack Gensel, who's writes a lot about firmware, says that on average, for every 1,000 lines of code, we'll have between 10 and 100 defects. Those numbers are very scary because our devices have hundreds of thousands of lines of code, maybe more. And so we're looking at, hundreds or thousands of defects. And some of these issues will be severe. Some of them will be security flaws. You probably won't be able to ignore all of them. And so you'll have to be able to do something about them. And last but not least, no matter how good your QA processes are, some issues will only be found in production. Why? Because if you think of a bug that happens once every 10,000 hours, it's very, very, very hard to find in QA. But once you have 10,000 units out there in the field, it will happen every hour. The law of large numbers is really tough there. I have a quote on the right, which I'm not going to read in details, but what it illustrates is that even NASA needs to debug after launch, right? In fact, I think they updated Curiosity, the Mars lander. They updated the software many times after the rover landed on Mars. Talk about an over-the-air updates. That's more like over space updates. I don't know what they call those at NASA. Okay, so if we're going to face this, if we're going to have to keep working post-launch, what can we do to make this the least painful possible? And I'm calling these techniques fleet reliability engineering. This is a riff on the software world, where they do what's called software reliability engineering, SRE. Fleet reliability engineering is the engineering practices, infrastructures, and tools that we can use to manage reliability at scale post-launch. And I look at three main techniques. And at Memfault, these are things that are our core business. Fleet reliability engineering is what we do. And those techniques are having a robust over-the-air update system in place. Number two is collecting performance metrics for those devices. And number three is remote debugging. I'm going to use screenshots from the Memfault user interface to illustrate some of those ideas. But I want to emphasize that the ideas are not unique to Memfault, and that in fact, many of you already have some of them in place. So while I'm illustrating them with my products, obviously, you can build them yourself, and likely you have in some way. Okay, so first, robust OTA. Why does this matter? It's obvious, I think. OTA is your insurance policy against issues, right? Like if there's something wrong and you don't have OTA, your only option is a recall. And this is why in some industries, we still see major recalls, right? But if you have OTA, you may be able to just push an update to your devices and keep going. One thing that I emphasize about OTA is that you have to have very, very high confidence that your OTA works. I have done a whole webinar on OTA, and I encourage you to watch it. We will share the link afterwards, because architecting your OTA correctly will make it more likely to work. But also you need test coverage. So I'll tell you at Pebble, for example, every night we did 100 over-the-air updates with iOS, because the Pebble Watch was connected to both iOS devices and Android devices. It was it was connected via Bluetooth. And so we had in the lab a couple test watches, with a couple phones, and every night we did 100 updates with Androids, and we did 100 updates with iOS. And before every releases, we did 100 updates with each. And if you didn't pass that test, you weren't allowed to ship a release. So something like that. And even if you start by doing it manually, right? Like you don't need a test rack to do 100 updates. It's a little time consuming, but it's worth it. So your OTA system at the very least should support three features. It should support what we call cohorts, or basically deployment groups is what it's called sometimes. It should support stage rollouts, and it should support what we call must pass through releases. And I'm going to talk about those three things very briefly. Cohorts. So what is cohorts? Simply stated, it's grouping your devices and updating each group separately. It's obvious that you need cohorts because you're not going to update your whole fleet at once. You might have a group of beta devices. You might have your in-the-office devices that your colleagues have, your QA team, all those things. And so why you need cohorts is there a simple way to enable kind of test releases, A/B testing, other kinds of experimentation. But also if you're working with industrial customers, each of your customer might want updates on a different schedule. And so cohorts are a good way to do this as well. And here I have a screenshot of what cohorts look like in Memfault. Basically split your devices into groups, and you can assign releases to different groups. It's very straightforward. Number 2, stage rollouts. What are stage rollouts? Stage rollouts are the ability to push an update, a new update to your fleets incrementally. So starting with maybe 5% of your fleets, then 10% of your fleet, 20% of your fleet. The reason you want to do that, of course, is to limit risk. Every release introduces some risk. You might have a new bug. The update process itself might be problematic. And so by rolling out updates incrementally, you limit the blast radius and you prevent an issue from impacting all your customers at once. And so we typically recommend, you have a cohort of your users in North America, for example, and you do a stage rollout on that cohort. You start with 10% of them and you wait a day or two, no complaints, keep going, right? And you can actually even automate that process and have it, if you have feedback into your OTA system, you can tell it if there's no issues reported automatically, keep incrementing the number. And so here again on the right, you see what cohorts look like in Memfault, what stage rollouts look like in Memfault. You can select a normal rollout, which updates everyone, or a stage rollout, and you choose a percentage, and then we take care of the rest. And last but not least, your OTA system needs to be able to do what we call must pass through releases. Must pass through releases are releases which must be loaded on the device before future releases can be installed. So for example, let's say that you have a device on the 1.5 firmware and you want to update to the 3.0 firmware, but it happens that there's a migration in the 2.0 firmware. And so you need to make sure that it goes from 1.5 to 2.0 and from 2.0 to 3.0. And if you have a naive firmware update system, you won't have the capability to do that. It will just want to update your device to the latest firmware always. And so, but you're going to need the ability to shepherd devices through those migrations, especially because you'll have customers who haven't turned on a device for a year. And so you can't guarantee that your entire fleet is always up to date. Here again on Memfault, we just have a checkbox. You see it at the bottom here to say this release, you have to step through this release in order to keep moving. Okay, so that's OTA. And just for reference, we have about 5 more minutes and then we'll have the Q&A. So beyond OTA, the next thing that we need to be able to do is answer the question, how are my devices doing? Because post-launch, ideally, you've got more data than just the number of people calling in to complain to tell you whether things are going well or not. You don't want to just be releasing a product and sitting by the phone waiting for a customer to have something to say, right? Ideally, you have some hard data you can use to monitor your launch. So you want to answer the question, how are my devices doing? Ideally with some sort of dashboard. And we find that the 5 things on the embedded software that we care about the most are number 1, connectivity. It's where there's the most problems, your LTE, your Bluetooth, your Wi-Fi connectivity. Number 2 is battery life when applicable, memory usage, sensor performance, system responsiveness. The system that collects those metrics needs to have 3 essential characteristics. It needs to be low overhead. You don't want it to impact the performance of your device. It's a little bit of the observation principle where, of course, observing something changes its behavior, but you don't want the behavior to change too much. Number 2 is it has to be easy to extend. If you want to add a metric that you're collecting, that has to be easy. It can't require 3 different teams to collaborate. And number 3 needs to be privacy preserving. We fall under a lot of regulations these days in California, in Europe, and other places. And so your metric system has to have privacy built in from the start. And so typically we see two different use cases for those metrics. The first one is looking at individual device metrics, so collecting data points around connectivity, around battery life for individual devices. And you can see on the right in Memfault what that looks like. But again, there are other ways to do this than Memfault. And you can see, all of these different metrics in a timeline for the device. You should be able to do that and look at different time ranges and investigate. When a customer calls and says, my device has bad battery life, you'd want your customer support team to be able to pull up this device and say, oh, yes, I see your device has bad battery life. And then you want your engineer to be able to pull that and see that the battery is correlating with how much we're writing to the flash, for example. And so this is all possible with a strong metric system. And of course, beyond that, you want some level of aggregation and dashboards, because you're not going to look at individual devices all day. You want something that tells you overall the fleet is doing well. So in Memfault, we'll let you create kind of different aggregated graphs of the metrics that you collect. And you want to be able to use that, use these aggregates to understand overall fleet performance and quickly identify trends. So you might put this on a TV in the middle of your office, right, to see how these metrics are moving over time. And of course, last but not least, your metric system need to have some way to configure alerts, because you're not going to be looking at the dashboard all the time. So if something happens, like all of a sudden a spike in CPU usage across your fleets because you shipped a new release and that new release has a bug, you want an email, you want a Slack message, or maybe even integration into your incident management systems like Ops Genie or PagerDuty. And so some way to configure those alerts so that you find out about things before you look at the dashboard when needed. In Memfault, you can create those alerts. There's conditions. It's a pretty sophisticated system. You'll need something that looks like this. Last but not least is remote debugging. Remote debugging is about simplifying this flow, which is, I think you're pretty familiar with it. Once a device is out there, how do your engineers get to debug a problem? Typically, you have a number of customer reports that tell you that something is broken. They'll tell you that audio drops randomly or Bluetooth disconnects. Note that customers tell you all kinds of things that may actually all boil down to the same problem. But because they experience it differently and because they use different language to describe it, it may not be obvious that they're all the same problem. It goes into your support team where you pay people to pick up the phone or respond to emails, and it's actually quite labor intensive. And then eventually you take that and you convert it into a couple different logs that you ask your customers to collect manually, and a couple RMAs, you get devices back in the lab to look at them. And those get sent to your engineers. This, of course, is really time consuming, right? It might take about 2 weeks. On a good month, it might take about 2 weeks for the data to go from the customer reports all the way to the engineers. And it's also really expensive. We're paying a support team. We have RMAs, which require reverse logistics systems in place, and replacing devices, which costs a lot of money. And what we want to do with remote debugging is convert that long and expensive process into something automated that can happen much faster. And so the idea here is to create a way for devices to report issues in an automatic way, which is then fed into a cloud pipeline which analyzes that data and collates all those reports into error instances that are deduplicated. So if you have 5 issues that actually, five reports that all boil down to the same issue, that have them merge into a single issue so that your engineers don't have to look at 5 things or 1,000 things for that matter. And that report should have logs and registers and memory and backtraces. And the nice thing about an automated pipeline, however you build it, is that instead of taking 2 weeks, you can actually go through this entire flow in 2 minutes of collecting all the issues, identifying trends, merging them into a couple reports that get shared with engineering. At Memfault, we do this with what we call core dumps. So core dumps at Memfault are automatic detailed diagnostics that are captured whenever issues occurred on the device. They come with logs and backtraces and memory, and they give your engineers the information they need to resolve the problem. Core dumps are not invented by Memfault. They're a standard way to do debugging. You want to collect the diagnostic data, upload it, and create some way to look at it. So this is the UI on the right that you see of how we do that. Okay, so that was a lot. Let's take a second to ask all of you which of these techniques you've put in place and which you haven't, and then we'll wrap up. I'm going to start the poll. And so we're asking you, and this is a multiple choice, so you can actually enter multiple things. I'm expecting most of you will have OTA in place, but I'm really curious to hear about, how much remote debugging do we see, how many metrics, and how many of you actually do none of the above. And I'll give you another 30 seconds to answer. I see about half of you have responded already. Let us know. Okay, 10 more seconds. Okay, let me share the results. And I think this is pretty typical. We see a lot of you have OTA in place. Great. As I said, it's your insurance policy. It's, in my opinion, kind of the lowest hanging fruit here. We have about half of you almost that do metrics. Fantastic. I'll be curious to hear what systems you use to do that. And then a handful have remote debugging in place. Love that. Maybe some of you are Memfault customers, which is even more fun for me. And of course, 7 of you have said none of the above. And I'd be curious to hear why not. Is this because you didn't have time, or is this because the value wasn't there for your specific program? I'll be really curious to hear. Okay, so this is the end of the talk. We're going to move into the Q&A, but of course, as the founder and CEO of Memfault, I like to emphasize that we believe that fleet reliability engineering is increasingly important, which is why we've built a platform that lets you do fleet reliability engineering at scale without having to reinvent the wheel and build your own infrastructure. And I'm always eager to hear what other fleet reliability engineering things do you do? What are the tools you've put in place you found really, really useful? So if you have more things, more tools, more exciting techniques that you've seen, I'd love to hear about them. Don't hesitate to email me at francois@memfault.com. My email is not hard to find. And with that in mind, we'll go to the Q&A. So if you have a question, you can click on the Q&A button in the Zoom kind of menu, and you can enter a question into the Q&A. At the moment, we have no questions. They were all answered by Noah and Colleen. So I can wait a couple minutes, but if nobody has questions or things they want to talk about by writing up a Q&A question, we can wrap up early as well. Okay. Jeet answers, how do you deal with day 0 updates when not all devices will be connected? So great question, Jeet. I think there are really 2 ways to handle this. The first one is that to have a connectivity step required, if your device is capable of connectivity, is to have a connectivity step required at unboxing. So you say, in your manual and your guide at unboxing, you have the customer connect over Bluetooth to a phone or something like that, using maybe a side channel that isn't how your device is typically operated, and guide them through an OTA flow by asking them to connect the device somehow. If the device does not have Bluetooth or Wi-Fi or isn't really capable of being connected, then you might actually guide your customer through a manual update flow, like plug the devices into your laptop's USB and run these scripts or go on this website. Obviously, if there's no way to update your device, you can't do a day 0 update. But if there is a way to connect your device, either by plugging it into something or connected an SD card into it, or by connecting it to Bluetooth or Wi-Fi, I would require that as part of the unboxing. Arian says, what has been a situation where remote debugging has saved the products? I'll tell you one. So we worked with a company called Skip Scooter, which did they did like scooters that you use to that you leave on the streets and that are left on the street and people can use to go from place to place, like renting them by the minute. And Skip Scooter, they did a case study with us, and you can read it on our website. But they ran into a major crashing issue in their like motor controller, which they ran into 2 days before launch during their beta tests. And so here, you had a major issue which had safety implications that got automatically collected by Memfault's diagnostic systems, and they were able to find the bug, realize what the root cause was, and ship a fix within 24 hours and launch on time. This is where having remote debugging versus having to send a technician out, first of all, identify that there's a problem, which is not always trivial, right? A customer might say, oh, the bike did something weird, right? But if you have automated systems, you can actually find the problem. Altamash asks how easy it is to incorporate Memfault. In general, building fleet reliability engineering does not have to be difficult. In the case of Memfault, it's about a week of work, maybe a little more, maybe 7 or 8 days of work to incorporate Memfault into a system, provided that it is compatible with our application. It's relatively straightforward, but even collecting metrics on a system isn't something that requires months of work, with or without Memfault. But yes, implementing Memfault is very straightforward. Abraham asks, how much bandwidth or data volume do you typically need for a single device to upload all of its metrics and diagnostics? So we typically tell folks to design their diagnostics and their metrics based on the constraints their system faces. And I'll give you a couple data points. First is we recommend collecting performance metrics at a low duty cycle. So let's say once per hour, you collect a bunch of metrics from your device, which means that actually the amount of bandwidth required is not that high, right? If it's 2 to 4 bytes per metric, and you're collecting 50 metrics, so 100 bytes, and you send it once per hour, right? 100 to 200 bytes once per hour is very manageable, even on a very low bandwidth system. And then as far as diagnostics, if you're collecting things like error reports, we've seen folks have success with error reports that are as small as a few hundred bytes. The more, the better, right? The more data you can send, the better. But for example, our customers at So Far Ocean are on a satellite connection that's really bandwidth limited, and they've been able to collect both metrics and core dumps with very little bandwidth. So and collect meaningful data, not just super high level data. So long story short, if you can spare 2,000 bytes per hour, you're already in pretty good shape. Jelmer, and again, I'm probably butchering a lot of your names, so I apologize for that. Asks, how do you do remote debugging with a device that has low power and spotty connection? Great question. We do this a lot. At Pebble, as you can imagine, we were on a super low power, battery powered device that was only connected when the user was near their phone. So the answer is actually very straightforward. You do it asynchronously. You store the data on device while the device is disconnected, and you upload the data when the device is connected. Remember, when we're talking about these metrics and these diagnostic systems that we're building, you don't need them to be real time. I think this is a mistake that many teams make. They think they need a fancy real-time dashboard where you can log onto a device and see every graph moving by the second. And that's not required. All that you need is some amount of data coming at some reasonable duty cycle, once an hour, once every 30 minutes. And so because we're talking about a few hundred bytes per hour, maybe a little bit more, you can store that on flash on the device, or even just store it in RAM while the connection is down, and then upload it when connection is available. This is something we have a lot of experience with, and it works quite well. Timothy Benson asked, does Memfault requires you to use your over-the-air update solution, or can you use the other features? You can absolutely use, you can actually use your own over-the-air update solution with the other Memfault features. This is not a requirement. And in fact, we see many customers who come and say, we already like our metric system, but we want to use your diagnostic system, or we like our OTA system, but we want to use your metrics. So that's absolutely okay. Martin says, how do you avoid that clients take your infrastructure down via denial of service? Anyone who has built infrastructure for IoT devices knows that this is tricky. A typical problem, for example, is devices who all check for updates on the same timer. And so, at noon on the hour, 1 million devices hit your server at the same time to check for updates, and then they take you down because you didn't, add some jitter or some randomness to when they check for updates. We thought about all these problems a lot at Memfault. We have millions of devices on the service, and ultimately the way we handle this is we do aggressive rate limiting. So if a device sends us, data, if a device tries sending us megabytes per second, we will decline it. We will turn down the data. So we have we've had to learn how to do all these things. Wow, lots of questions. We'll keep going. Arian asks again, on short timeline of less than 12 months, what's the minimum must-have feature? I'm guessing OTA, but anything else? I don't think that a 12-month timeline prohibits building good infrastructure. And this is the difference between, if you buy something off the shelf, you can go from 0 to functional in 2 weeks. You can spare 2 weeks in a 12-month program. But if you really, really had to choose, I only get to do one thing, of course, OTA is the bare minimum. Because with OTA, you can do the rest, right? You can ship your device with OTA, and then you can ship an update 6 months later with metrics, with diagnostics. So OTA is always the bare minimum. But I would contend that you can do everything if you're not building it from scratch yourself. Chris says, Memfault sounds like a great framework. The problem is that I'll have to convince the clients that it's worth the costs. How much does it cost, and is it cost effective for products in small quantities? I think, Chris, the devil is in the detail. Like, what do you mean by small quantities? What does cost effective mean for your program? We've worked with customers who have hundreds of devices, low single-digit thousands of devices, and we've, I think they were quite happy with the way things worked out. But yes, I agree. But the reality is fleet reliability engineering broadly is a worthwhile investment because it saves you more money than it costs you. And this is true of Memfault, but it should also be true of whatever solution whatever decisions you make when you design your product. So we've built a system that we believe is more than pays for itself, many times over, in fact. And if you get in touch, we can give you pricing for a specific program, and we can help you understand how the ROI is going to stack up. Nathan asks, what is an example of an alert that you've used or you've seen to catch issues on portable or wearable device? Yeah, simple, Nathan. Something that we often did at Pebble is we looked at how much power is consumed by the device in a given time interval. So basically, every hour we would collect from the watches how much the battery life went down within this 1 hour. And then we had an alert that says, if the P90, so the 90th percentile of that metric, is higher than a certain amount, send us an alert because there's a major problem with battery life and we might need to roll back an update. So that's one type of alerts. But also with devices that run out of memory, that's something that you might want to look at. There are many, many others. Can a Memfault be used with bare MCUs? Ask Greg. Yes, it can. Cortex M0s, no RTOS. We work with bare metal systems all the time. Soren asks, what pieces of software are you licensing? You can basically use it piecemeal, Soren, and you can actually go on GitHub and find our SDK. It's available open source, so you can check it out. But basically, it's you can get it piecemeal. Does Memfault have a Delta-based OTA system for Zephyr? We do support Delta OTA. Ultimately, your underlying system has to support it. I believe Zephyr does. So yes, you should be able to do Delta updates with Memfault and Zephyr. But Andre, get in touch and we can actually look at your exact requirements. And then last but not least, this was a marathon of questions. Thank you, everybody. Soren asks, what is the memory footprint for these features? The memory footprint is about 4.5 kilobytes of code space and about 1.5 kilobytes of RAM. So should be fairly accessible on most 32-bit microcontrollers. Okay, that's it for the questions. I see some of you have started to drop off, and we're at the end of our time. We really appreciate your questions, your time, and your engagement today. I hope you found this talk interesting. Please share some feedback. We'll send you a small survey. We always love to hear what is it that we could have covered better. Was the topic interesting? Was the content interesting? So really appreciate anything you can share there. I hope you have a fantastic day, whether it's the end or the beginning of your day, like it is for me here in California. And I look forward to talking to you on the next one of these webinars. Bye, everyone.